with 4, so the previous ones we did were, we were subtracting both. In number 4, we have similar coefficients, not the exact same, but in order to eliminate those, would we add or subtract? And if you're not certain, you could check it. I did this yesterday. But if I did 4 plus a negative 4, I would get 0. But if I did 4 minus a negative 4, it would not eliminate. So double check yourself if you're not sure. So we would add the two equations together. So we have 0, 16y, and 16. And we could solve for y, divide both sides. And then pick one of the equations, put y back into it, and solve for x. Let's say I chose the first one. We have 4x plus 9 equals 5. And then you could keep solving for x, get rid of 9, divide both sides by 4. So negative 1, 1 would be our solution.
Can you leave it there for a minute?
Questions on that? We could do 5 and 3.
Alright, you can go ahead.
No, so after you get the first variable, you can put it back into either one. So if you use the second one when I use the first, as long as you get the same answer here.
Wait, what did you add instead of subtracting the first percent?
Because we're trying to eliminate the variable.
So like in all of these you have to add?
No. And all of them we have to eliminate. So
You
however
can go
you
ahead.
can eliminate adding or subtracting, do that.
No, I was saying I was done.
Okay. For number 5, these are not exactly lined up because the equals is off. So we have a choice. We can either rearrange the first one to look like the second one, or rearrange the second one to look like the first. Do we want to move the first or the second? Okay. So if we're moving the first, we have to move the y on the same side as this. So subtract. Now, everything's lined up. Do you have a question? Why did we move it?
Sure, yeah, like,
Okay.
why'd you minus y? I know
They
it's a
have to
dumb
be lined
question.
up. Everything has to be lined up. The x's, the equals, the y's, the consequence. And they weren't before. So now that they are, what's the common coefficient that we're going to eliminate? I asked the wrong question. Which variable are we going to eliminate?
X. Negative X.
We could do that, but those don't have the common coefficient.
Oh,
Y does.
Y.
So that would be the easier of the two. Would we add or subtract these? Subtract. And if you're not certain, again, you could check it. Negative 3 minus a negative 3 would give us 0. Be careful with your negatives here, though.
We have to like make it 0.
Correct. 2x minus a negative x would be 3x plus 0. 10 minus 11 would be negative 1. This one we're going to get a fraction for both the x and the y. It's not going to be nice, but we're going to do it anyway. So now you have 3 different choices of where you can put this back into. Either original or the one that you choose. I'm going to put it back into the very first one. You can pick whichever one you want. be off the side here. It'll look really smushed for a second. And you can do some of this in the calculator. Subtract 11, you'll get a not nice fraction.
Basically, go straight to
This is low battery.
You can get a different one. I don't have any batteries. Waiting on the order for batteries to come in. Hasn't come in yet. When you get here, you can do one of two things. Divide both sides by 3, but then you'll have a fraction within a fraction. So you have to either put it in special on the calculator, or to avoid that situation, you could take this 3 and flip it and multiply it instead. So our ordered pair would be negative 1/3, negative 32/9. Questions about that one? We're not going to do 7. I just want to point out that there should be an equal before the negative 10 in number 7. But let's do number 9. Everything is lined up, but do we have a common coefficient? No. That doesn't mean it's no solution. That just means we have to make a common coefficient. So you can choose whether you want to eliminate the x's or the y's. In this case, it might be easier to eliminate the x's. So we have to somehow make these numbers the same. Right now, there's a 2, there's a 1. I can multiply this entire equation by something to make it the same. What could I multiply that by?
Like multiply everything.
Yes, but really we just want it to be the same as this.
Oh,
2. So if I multiply everything by 2, because I can't just multiply the x, I have to multiply everything. Then that entire equation is going to change. So we have 2x plus 6y equals 12. Now we have common coefficients and the rest is the same. To eliminate our x's, would we add or subtract? So go ahead and subtract. We have 0, negative 7 minus 6 would be negative 13y. Negative 1 minus 12 would also be negative 13. And divide. So again, you have 3 choices as to where to put the y equals 1 or the 1. The first 2, the original equation, or the one we solved. Pick one and do that. I'm going to put it into the first one. What is your x value? value. 3. So that would be an example where we just changed one equation, but sometimes you have to change both. So like in number 10, we again don't have common coefficients. You can choose, do you want to eliminate x's or y's? I'll let you guys choose this time.
Why?
Okay, so if we're getting rid of our y's, we have to make these both the same number. So we have to think of something they both go into. Say that number again.
4.
They both, 3 and 4 both go into 4? 12. I could multiply this by 4 to get 12, and this by 3 to get 12. Sometimes the easiest is just taking whatever the numbers are and multiplying each one by each other. Sometimes that's not the lowest number, but in this case it is. So then once you have your two new equations, now we have common coefficients. Would we add or subtract to eliminate? So we have negative 3x plus 0 equals 6. Solve for x. Once you get your variable, now you have 4 choices, the 2 originals or the 2 you just changed. Put it in one of those and solve for y.
So you're just putting it back in the equation.
Oh.
It's just taking the second because I'm writing on the wrong part of the board. Any questions about that process?
Can you leave it there for a second?
I'm going to show you one example where it's a special case, and then any you guys want to see, and then you'll have time to practice. I'm trying to remember which ones are the special cases, I think. Let's go back to number 7. Right now we have similar coefficients. Do we want to eliminate the x or the y? Which one? Okay. So if we're eliminating x, would we add or subtract?
Subtract.
Okay. And if we subtract, what happens to both the x and the y?
They cancel.
They cancel.
They
Yeah,
both cancel. So 0 plus 0. And then negative 10 minus negative 13 is really plus. This would be what type of solution?
No solution.
So if it's a special case, your variables cancel. Now it could be like this where you added or subtracted and they immediately canceled. It may be like, I think 14 as a special case, but I don't remember off the top of my head, where you have to add, multiply and then add or subtract, and then you'll see that they might cancel. Did you have any questions about that or any other questions on this page? So then for the rest of the class, you guys can be working on the rest of these problems. The delta math on this that's due on Friday. Tomorrow, yep. If you didn't do the substitution or graphing delta math, you should be working on that from last week. Tomorrow we're going to start word problems, our favorite thing. But use the time wisely. Let me know what questions you have.